Okay, welcome back. Lesson 11, solving equations. So this will be a really light intro to solving equations, and we'll do more complicated equations in the future. When an equation contains a variable, deciding which value or values of the variable make an equation true is called solving an equation. A solution of an equation is a value for the variable that makes an equation a true statement. Example, I give you this statement here. You tell me whether it's true or not. Determine whether a number is a solution. Is 6 a solution to this equation? Well, a lot of people start by grabbing 6 and storing 6 in place of the variable. So 5 parentheses 6 minus 1, does that make 30? Question mark. Well, clearly 5 times 6 is 30, but minus 1 is 29. And since 29 does not equal 30, the answer is no. 6 is not a solution. Okay, so the answer to this was no. So initially we start, when I ask you if something is a solution, we just literally store it in place of the variable, crank it out, see whether it comes to be a true statement or not. Now, let's go a little deeper, the addition property of equality. If A equals B, then basically A plus C equals B plus C. And that's a fancy way of saying if I add something to one side of the equation, I must add it to the other to keep things fair and balanced. And if you just think about this, right? You have a balanced equation, right? Think about a true balance in your mind. Okay? 3 pieces of chocolate on one side, 3 pieces of chocolate on the other. If I take one piece of chocolate off of the left side, I better take one piece of chocolate off on the right side to keep it balanced. So balancing an equation is going to be very, very important in our near future. So in other words, the same number may be added or subtracted from both sides of an equation without changing the solution to the equation. So this enables us to do a lot when working with equations. If we know that we can add a certain quantity to the left side and add a certain quantity to the right side of the equation to keep it balanced, then we can manipulate equations, which we will do shortly. Okay, example. Solve this equation mentally. I just noticed a typo there. And then okay, in this example, let's solve this equation mentally and then think about what steps we could write out if somebody was forcing us to write out some steps. Okay, so X stands for some unknown thing, some unknown number, right? Okay, so something minus 4 equals 3, right? Now some people just look at that and instinctively say, oh, X must be 7 because 7 minus 4 makes 3 equals 3. So you feel that X is 7, and that's just based off of instinct, right? But now the catchy part. We have to use things like the add-up property of equality and soon the multiplication property of equality to help us write out steps for when these equations become more intricate and robust. Okay? So let me ask you this. It's all about connections. How is X connected with 4? By subtraction, right? But what's the opposite operation of subtraction? Addition. So to undo, in other words, undo. To undo subtraction, you're going to add. But whatever you add to one side, you got to add to the other side of the equation. Then you will have X equals 3 plus 4, which is 7. See, so you've written out a step, and you've done what's called the add-up property of equality. Says whatever you add to one side, you must add to the other side of the equation. Okay? So, and why did we add 4? Because negative 4 plus 4, you know, this minus 4 plus 4, they cancel. And that's the whole goal, is to isolate X. Goal achieved. Isolate X. Okay? Now, a lot of people say, look, I could have got that answer 7 without lifting up a pencil. I know, but things are going to get more intricate very shortly. Let's try again. Multiplication property of equality, as you imagine, says that if you're going to multiply, if A equals B, then AC equals BC. And it basically says if I'm going to multiply one side of the equation by a number, I have to multiply the other side by that same number to keep things balanced. And likewise, I can divide both sides of the equation by a value, as long as that value is not 0. Okay, let's practice another one. Solve this one mentally and then try to write out the steps. Now, most people look at this and say 4 times something, because 4 is connected with x by multiplication. So 4 times something makes 8. Well, clearly that something must be 2, right? So x is 2, and that's just figuring that out mentally. But what if you had to write out a step? So again, it's always that undoing process. 4 and x are connected with multiplication. So to undo multiplication, you're going to divide both sides by 4. Use the opposite operation. How come? Well, then 4 divided by 4 is going to cancel, and you'll have 1x. 4 divided by 4 is 1, so you'll have 1x equals, but then 8 divided by 4 is 2. 1x means the same thing as x, so you have x equals 2. So we do want to practice just this notion of this idea of divide both sides, to isolate x. Divide both sides by 4. Let's see what else we have cooking there for today. Oh, here we go. Example in our near future. Now, I told you things are going to get more complicated. So in the next podcast, we're going to review algebraic expressions and distributive property and all this, but I'll give you a little window into our future. If I wanted to solve this, I always put my eye on the equal sign, clean up the left side of the scale, the balance, clean up the right side of the balance, and then try to isolate x. So if you're rusty on the distributive property, that'll take us to 2x plus 4 minus 3x equals 2x minus 7. I'm just giving you a window into our future. Combine like terms via adding like terms, so you can even say add like terms. So 2x plus negative 3x, or 2x minus 3x, is negative 1x. And then you have your 4, and then you have your 2x minus 7. When you arrive there, see, this is something we haven't done a lot with yet, but it's coming. Letters on the left, numbers on the right. Letters on the left, numbers on the right. You want to move letter, number, letter, number. Move your variable expressions to the left. It's good to get in the habit of that. Okay, so minus 2x, minus 2x. Then negative 1x minus 2x is negative 3x plus 4 equals negative 7. This number, I want to toss it across the equal sign, but I can't just toss it. I have to use the opposite operation. So opposite of adding 4, minus 4. So now I have negative 3x equals, and then negative 7 minus 4 is negative 11. And then final frontier, divide both sides by negative 3, and a negative divided by negative is a positive, so you'd arrive at 11/3, which is a decimal, but don't worry about that till later. Anyway, if that equation was, you're not ready for that, that's okay. We have work to do before that. I just wanted to give you a window into where we are headed. All right. See you on the next one.